Like, why can't we just put really big batteries in New York City, in LA, in Chicago, and all these big places? And then the question was, of course you can't, because they're not safe, because they cost a lot of money, they cover a lot of land, they can explode, and then like if you use them a lot, they die. And then so I started the journey doing that. In 2014, I called the first major integrator in the US, Unicos. You remember them, right? And they were really cool guys from Germany to open an office in Austin. I said, can we? And then I thought, if I use it the way I wanted to use them in New York, which is to sell a lot of power, do all this, these things wouldn't last more than a year or two. And I thought, gee, all this money would be in the garbage. So as an entrepreneur looking to take care of this, I realized that I'm running against the wall. There's no other way but to basically reinvent the wheel to the extent that is needed, and decouple the problems for where they are and redesign in a way that works for New York, works for any load pocket. And then it truly can integrate DRs, can integrate load from anywhere it comes, but essentially acts as a power source for all the way around it. And that's where we need to go today.
Are you speeding the energy transition? Here at the Clean Power Hour, our host Tim Montague bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. Today on the Clean Power Hour, we're exploring energy storage as a service for some of the toughest markets in the country, like New York City, where space, safety, and regulation make grid resilience a real challenge. My guest today is the founder of Karh Energy. Welcome to the show, Christian Farivar.
Hi, Tim. Thank you so much for having me. How are you today?
Oh, dude, I am awesome. It's great to be alive. I'm just back from Toronto, where I was visiting what I call my AI overlords. It's a play. They're not at all my overlords. They're my. It's a company called WSI that I'm a certified AI consultant through them, and it was great to visit with Mike and Seamus in the flesh in Toronto. First time in Toronto, but Christian. Tell us a little bit about yourself. You have a really interesting backstory, and you're also living in Canada. So tell us a little bit about your background.
Sure, thanks. I'm here in Montreal, in Canada, on the French side of the country. My background, I've been in this energy journey for a long time in different capacities. I recently graduated from Harvard University in the field of management, and I teach some courses now at Harvard alumni entrepreneurs on entrepreneurship. So I'm dealing a lot with innovators, which is really exciting. I've Karh, which was founded about 5 years ago, around 2020, just around the time that the FERC ruling came out. was not was incorporated then. It was we came up with the concept years ago. I came up, and it was a research that I've been working on for a number of years. So
When you refer to FERC, you're referring to 2222?
exactly, the 20 FERC 2020, actually it's called by the year, and that's the when during it was FERC 2020 allowed was initially allowing DERs to get on the grid. And that was, to me, it was a sign to start the company then and there. Because back in 2014, I had jumped in to do some research for an energy trader, and who, I was very interested to get into energy at that time, electricity specifically. The excitement had come from I had a previously successful career in music business, which I retired from. I worked with big artists like Bon Jovi and Kanye West and all this kind of stuff on shows, but it was great. But I left. I wanted to go back to my other passion, which was engineering and energy in particular. And I studied I did the research on history of energy, and then I found out that it wasn't what it seems. It was a lot more complex. And so that got me into the energy storage journey. At that time, we knew that getting a very cool, very strong project in New York or places like that, particularly I was looking in New York from the beginning. It's where I've always been passionate, and I've had a lot of experience working with New York and there when I was in music. So it's someplace that's home to me. I knew that, the research showed that it's just not going to work, because it was just the utility market, the way the rules and regulation was not ready for it. So did a lot of baking and developing the ideas and the concepts for the company and what the product and technology and business model would be. But when FERC 2020 came around, we knew that that's the moment we should launch it, because now it's possible legally to really get on the utility grid.
Yeah. So we are at the right time, at the right place for sure. I do want to dig a little deeper into your background, because it's quite unusual that somebody would come from the pop music industry in New York City over to energy storage and be a founder of quite a technical, what is an OEM. You are a manufacturer of energy storage systems. So how exactly do you make that translation?
That's a great point. So first of all, I'm glad you brought that up. So in terms of what we're building, it's really, you don't arrive there on day one. It's just a whole series of things build up, and you're there. We are building power electronics. We're designing semiconductor device. We're designing our own thermal technology innovation. We have completely new thermal technology stack. We have completely new HVAC stack. We have redesigned the rack. We have literally gone at the cell level. We've designed our own battery management system. So and our own AI, which is just incredibly good. In other words, we looked at the entire way that energy storage was from an outsider lens, which I think is really helpful. And that's what I did. And I thought, this is a great technology, but nothing about it is working the way I would use it. And I knew where it needed to happen for it to work. And for it to work was that, what is the biggest problem was, as I said, I knew New York City, right? I had a background in entertainment. It was an accidental background, and I really enjoyed it. Prior to that, I was always interested in engineering. And when I was a teenager, I remember accidentally sitting in the library and reading about, I used to read science magazines, by the way, since I was a kid. So I was a top science student. And I was also very interested in art, and I studied both of them. Left, right, basically left brain, right brain. But I remember reading about how power production, was the number one source of pollution in the world. And I was right away interested in studying bacteria that you could drop from airplanes that could kill pollution. I thought that would be really cool. It was always about cities for me. I don't know why. Because I was a big city person. And then I thought, well, that might not work. And I thought, why don't I maybe it's the regulation side. I remember working for Greenpeace for a year, and that was really depressing. And I thought that won't work. So I want to do something else. And I thought to do environmental law. Then that didn't work. And then I'm studying history, philosophy, and history was really where I went back into energy again. When I discovered the history of electricity, why, for example, cogeneration didn't take off in the US, I realized that my passion was in energy. After I retired from music, I remember Dick Munson, great historian, read my paper and thought it was really great. And I thought, this is my calling. I went back and studied another couple of years of engineering. So, I didn't finish the engineering degree, but I went back at it.
Mm-hmm.
So I have what I call what they call bilingual capability. I can speak technicalese, and I can speak businessese, if you will, to say. And I think that's the kind of skill that has helped me build Karh the way we have been, and bringing a really good team. And when I was working in music, I was putting multi-million-dollar projects out of thin air and ensuring these are done at a quality that is just absolutely perfect. I was an independent promoter. I was an outsider, and I was managed to work with the biggest of the biggest of the biggest. And they liked working with me. And so I think I brought that capability, which is, I think, just this, ability to bring these complex things, all these moving parts together, that became something that I just became good at, which is now used in Karh. We're bringing so many different kinds of technologies together, building a vertically integrated, I would say, sort of a powerhouse technology that at the core is built on battery storage, but it's a lot more like a computer. and there's a lot of similarities between computers, by the way, and batteries, and I'll get into that if you like.
Yeah, I would love for us to, let's do a deep dive into the technology to the extent possible. Okay, like you have arrived at a realization that we need better batteries that are suited to certain environments. And then maybe we can swing out again and talk about the grid and the transition that we're on, this journey to clean the grid. A couple of years ago, I documented large-scale storage needs, and apparently we need about 6 terawatt hours of ESS on the grid to green the grid. And of course, that'll go up as the grid grows, and we are going to triple or perhaps quintuple the grid. And now we see the AI explosion happening in real time, and prices are going up. The grid is humming and being stressed by the build out, but also by climate change. The important statistic for my listeners on this front is billion-dollar storms used to happen every 90 days in the US. Now they happen every 19 days. So the frequency of storms has gone up by a factor of 5 almost, 4.7. Okay, that's a lot. So the grid is super challenged both by itself and by these external forces. But what is Karh?
Yeah, I mean, before we understand what is Karh and why it is, I think you brought a very important point. We need to understand the auspices under which I looked at the problem space and what needs to happen. At the core, when you sit around New York City, which I spent a lot of years in time in, back and forth, you're sitting in literally the capital of the world. This is where all the businesses, all the industry is happening. And you have the most amount of electricity, peak demand is happening there at the same time. You've got grid congestion building out, and you're looking at this last 10 years. And I love you said you worked on this podcast. You've been following the energy history of energy transition for the last 10 years. This goes back many years ago where and this is not just a New York problem. The way that the power systems are built, any major city you get into, New York, LA, Houston, Chicago, you've got transmission coming around, and then you've got distribution that it steps it down and brings it to the population. These transmission lines can only take so much. They're like a highway. Once you get to about a few percent, you have to start to have a loss. I think once you get to 50%, the losses, 50% capacity of transmission lines starts to have a few percent. As soon as it goes a bit, the curve is even higher. You can get into 50% loss. So all that power coming in is just gone. Mm-hmm. So that is limited. These HVDC line that is coming in New York now, which is essentially, a DC line, is what I've been hearing is that it brings back New York to the problem it had literally 20 years ago. And that's how long it takes for these cycles to occur, because it's just the world is getting more complex. The way to build these systems takes a lot longer. The research, so all this is happening at once. While on the other hand, You've got innovation that has made use of electricity for powering buildings, for powering transportation, for powering industries, suddenly a much more cost-effective. Innovators have made these technologies that allows consumer industrial side production of energy that can potentially compete with buying it from grid operators. And yet then vice versa, they're trying to connect to the grid. So all this is turning the grid as these distributed resources, electric vehicles, buildings, electrified buildings, and then data centers, which are these all have a certain similarity they call high-load technologies. In other words, they can suddenly increase the load by a lot in a very split second and then change. Several trucks from a company arriving in a particular corner in New York could suddenly require several megawatts of power in just a few minutes, and the grid is just not designed for that. So what utilities and power producers have been doing is they've been adding what's called firming power, capacity around that, which is just having a lot of standby power to watch out for these gruely changes. So all this is to say that it has been well known that, and I think there was actually a great paper by Judge Tomain about the story, how the U.S. system works, is that the U.S. government administration has always been focused on getting rid of gross misconsistencies, and so it was known that it's important to have a lot of power mix, a lot of different dynamism to just put that away as being a problem space. So we're getting in this place where we have lots of different power systems. Like you said, there is inverter based, there's gas, there's nuclear, there's competition of different. The problem is though that at the end of the day, they all have to come to the load pockets. Load pockets are places where the load is just really intense, really, there's a lot of layers of power needs, power services need. And so there's no solution to that. You can have, and battery storage, by the way, has been thought to be this great, shapeshifter. It could really help do a lot of things for different reasons and different things. And one of them would be to, time shift. As there's a lot of cases. But bottom line is that for this purpose, in order to look at load pockets and how to relieve the load pockets, the long-standing wisdom has been, the easiest thing would be just the power plants in big cities. And look, that's really, if you had a big power plant in the middle of New York or LA or Houston, you don't have the transmission problems. So the electricity would be cheap. The problem is you can't build power plants in New York or LA. It's just not going to happen. The space, the pollution. So
yeah, I think but New York, in New York's case, right, there are power plants right around New York, on Long Island.
Yep.
Right. But to your point about load pockets, aren't distributed generation resources an answer to load pockets?
So the short answer is no, but the long answer is yes and no. Mm-hmm. And I'll tell you what that means is that when you are, and this is exactly what we're into. So the load, the grid, the power grid as a whole, what they call the world's biggest machine. And if you listen to a Jim Robb podcast on this about 5 years ago, fantastic conversation he did, was that the power grid has always been based on a known system. You've got these centrals, utility, power production sources, they get interconnection, who they are, what the load is. And, electricity is produced and used almost instantaneously. The idea of storing it a little bit, like you do with grain or wood or other commodities is brand new. It's coming in, but it's still very tiny. Then you've got this topology, which we're moving to, in which power production sources can come from many little places. Many of them are not even big enough to have a wholesale permit, right? They can't be. So you're going from a known state to an unknown state. So if you have a small amount of DERs, and a few resources, that's okay. But again, these DERs, they are not able to get on the grid fast enough. If they get on there, they still need to put a lot of costs and other expenses into there. And then at the end of the day, you still need to get on the transmission line and bring it to the market. If you look at it, right now they're putting all this wind they want to put near New York. How are you going to get that into the New York City? And how are you going to get that into New York City in a time where it's needed the most, vice versa? So the short, obviously answer is to have really big batteries. It's just that that's not possible to do. But we said, why not? And that's what we built Karh. Why can't we just put really big batteries in New York City, in LA, in Chicago, and all these big places? Mm-hmm. And the question was, of course, you can't, because they're not safe, because they cost a lot of money, they take up a lot of land, they can explode. And then if you use them a lot, they die. And so I started the journey doing that in 2014. I called the first major integrator in the US, Unicos. You remember them, right? And there were really cool guys from Germany to open an office in Austin. I said, can we? And then I thought if I use it the way I wanted to use them in New York, which is to sell a lot of power, do all this, these things wouldn't last more than a year or two. And I thought, gee, all this money would be in the garbage. So as an entrepreneur looking to take care of this, I realized that I'm running against the wall. There's no other way but to basically reinvent the wheel to the extent that is needed and decouple the problems for where they are and redesign in a way that works for New York, works for any load pocket. And then it truly can integrate DRs, can integrate load from anywhere it comes, but essentially acts as a power source for all the way around it. And that's where we need to go today.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. So when you say a really big battery, what I think of is a building-sized battery. You've got a very dense built environment in New York, obviously.
Yeah.
But how is what you're developing then different than what Energy Vault, for example, is doing?
I mean, just, as I said, I don't want to, and I think Steve Jobs did this great job. So you don't want to talk about people who are serious or not. I said, all these great companies are doing great things. It's just not what we're doing. There is a lot of companies working on different kinds of power storage. There's people saying that the big solution will come from changing the cell technology. And, I think building a new cell technology is like developing a new drug. There's only a handful of drug companies that can manufacture them so large state. And same thing happens with batteries. There's a lot of companies making, cool integration with existing technologies and reorganizing in a way that is good, but scaling them in a large scale and making them last a long time such that it makes alpha and makes worth doing and you can run it. No one has been able to accomplish that in a big way. There is really, there are integrators in New York right now who have hundreds of millions of dollars in cash that are trying to build these sites in New York. They can't find land. They can't find, and the economics doesn't work. The unit economics of putting, any of these batteries just doesn't work because you can run them, let's say, one cycle a day. And then, but that's not what the grid, that's not the way to make good money off of them. And then you have to run them one cycle a day. Then they want to make you, the batteries are only worth like 80%. It's just this, the economics doesn't build up. Our economic right now is like, we're able to run at a level of, let's say, 20 megawatt, module, if to say, and these are like sort of like I said, that's the size we're going for, and larger than that. We can generate like anywhere from $7 to $8 million a year net, and that is unseen numbers. We're looking at unit economics of like around $45 to $50 a megawatt hour, and that is like getting into cost turnout and cost that is like competitive with generating hydroelectric. So these unit economic is only possible when you completely reimagine the battery. And I said, I brought that metaphor is that a battery, if you think about it, is a lot like a computer because computers, are adaptive machine. They take electrons, they do different things with them. But guess what? Batteries are also playing with electrons at just a very larger amount. And so if you think about the battery like that, it kind of frees your brain like, wow, that's true. If the battery can be like a machine, what can I do for this machine to run really well? Well, you need to make sure that if it runs hot, there's no problems, right? You need to make sure that the HVAC, the thermal management is really well. You need to make sure that it's designed to be incredibly clean and efficient. And especially if we're running it to make money from it, which was what we're focused on doing, then you want us to generate as much efficiency as possible, which is not the kind of system you can buy in the market. And it's certainly not at levels that are efficient for cost, life, repair. We're going into a world where like we have to look about our supply chain. where's the supply chain coming from? What happens if things go wrong? All that becomes an issue you need to solve as an entrepreneur when you're trying to build power systems.
You've put a lot of things on the table here, so we need to unpack this a little bit more methodically, I think. You're talking about a 20 megawatt building block.
That's bigger than that.
So you're designing and manufacturing a battery, and then planning to deploy it. You're not just a battery maker. You're actually a developer that wants to be an asset owner, I believe. Is that right?
I mean, yeah. Where we see the need is to sell the electricity. There's nobody needs more machines, and if they do, it wouldn't be worth it for us to sell it. I feel like if you look at, SpaceX, you can't buy a rocket from them. But that's not where the problem is. The problem is you need to get satellites in space. So they made a reusable rocket, and so we've made a battery that lasts a long time. If our asset life is approximately right now, we're looking at about 30-year asset life at the very least. I think it's gonna.
What is the core technology that you're working on? Lithium iron phosphate?
There's core technology I could talk about, but there are 3 levels of technology that come together. One is at the application level. One is at the system level, one is the infrastructure level. They're kind of like 3 groupings, if you were to say. And so that kind of makes it a vertical integrated stack. At the core, we're using regular chemistry, cell chemistry.
Lithium iron phosphate.
Lithium ion batteries are of different kinds, or like you said, like the lithium ion. We're also open to other technologies that come. We're essentially a chemistry agnostic system, so that's how the system's designed.
Okay.
Which is a good starting point to look at how it's unique. In other words, we looked at how battery systems work. You don't want to be stuck with a single cell provider. And if you were to look at the airline industry, why never you want to get into is because if you want to start an airline, you have Airbus or Boeing, and I don't want to be in a position where we start to scale up a company and something happens and then we can't get our equipment, we can't get our cells. So we've decoupled that. So we're cell agnostic, we're chemistry agnostic technology at the core. That's the first layer.
And then, but you're building. Let's just say you're building a 20 megawatt container, and then putting how many of these containers? Like, what's your vision?
Like
what's your vision for New York City? You're very focused on New York City initially.
Yeah, I love New York.
And on some level, I can appreciate that, but on some level, I go, well, why go to the most difficult place to install a really big battery?
I love that question, and there's 2 reasons for that. First of all, I didn't even think about it. It's just like I was like New York, because it's a city I know the best. I used to work in music and culture, and I was always active there. It's just where my connections came. Like I got invited where it was during the pandemic by a friend who I knew from the data science world. He said, I'm starting an Excite. I want to come in and join. And I was like, sure. But if you make it New York, you can make it anywhere. That's what Frank Sinatra said, and it's true. It's really the center of the universe. But more than that, and I didn't realize it until later, it's like the problems in New York are at so many levels more sophisticated. And once you learn how to do it there, for us, the learning experience has been really helpful because it helped us build technologies and design things in a way that is so much safer, so much better, that now we feel like then taking it elsewhere would be a lot easier. In other words, the problem is you're looking at so many levels of needs of, you need to provide, you look at the layers of problem in New York when it comes to the load pocket. You have load problems, you have frequency problems, you have peak demand problems. Then you've got integration with all these DRs coming around at the distribution level. You have now a very small level of, consumer level DR, but imagine when that goes up, the distribution grid is just not prepared for it. And a lot of people don't like to put smart meters from Con Ed or other big utilities on the property because that's kind of the off-gridder mentality. So many utilities are in the dark about like what's going on at the topology of these properties. They're not fully aware. So the compounded problem is really the kind of problem that excited me. I thought that's great because I'm thinking exactly about these things. I'm thinking about like, why can't I make a battery? I always start from the beginning. I said, I want to build a battery that does all of these things. So it has to work all the time. It has to work really robustly. So we are going to solve, like we're running our AI right now. We just ran our test. We ran, we're doing 12x in profitability and revenue by literally bringing the price down. And we're making 12x profit than any existing AI that we've looked at. It's crazy. Like the numbers are staggering. So really proud of that.
Well, that's awesome. And, but like, I really think we have to be focused on the real world and solving real world challenges. And Absolutely. I get it that you're passionate for New York City. And so let's say you deploy a 100 megawatt hour battery in a specific geography in New York City. Like that's a big battery in America today. It would be 100 megawatt hour. And you do see 100 megawatt hour projects coming to the surface. Some of them are heat batteries, some of them are gravity batteries, some of them are lithium ion batteries. Batteries are good. It's a two-way device, right? It absorbs energy and it deploys energy instantaneously in many cases. In the case of batteries, what is then what? Like what are you achieving by attacking a load pocket?
Yeah. Very good question. So first of all, I think, our test project is going to be about 90 megawatt hour, but we're going to go for a lot larger and faster modular. We have a way to modularly interconnect at a faster rate, which we'll get into another time if you're interested. So what means when we put one of our power stations in a place, let's say in New York, in Brooklyn or Manhattan or anywhere where we get to work with the land operators, is that the scale, it has to be quite higher. So we're looking at 20 megawatt, 90 megawatt hour to start, but it will get really quickly into something like 350 megawatt hour or more. And so what that does at that level is that now suddenly we're able to bring in transmission. You're able to take care of the transmission constraint in a different way. There are a lot of lower cost, inverter based, could be gas, could be nickel. I don't think battery is a clean technology. I think it's like for us, because you can't really choose where the electrons come from, but ends up being always cheaper from inverter based technically. But you're bringing that power into the market during a time where it's not as the grid congestion is not there. So that's one opportunity right away bringing to the distribution area where you're in. Because when you're in a place in any geography you're in a load pocket, you're closest to the distribution place where you're at, right? So that's your network. That's where you have to go. You can't, intra network trading isn't really out there yet, right? So you have to take it. Let's say Farragut substation in Brooklyn, great place. So you're able to now bring lower cost electricity. You've got the utility nearby. You've got other off takers. There's all kinds of. If you look at some of the other developers in the market, there are a lot of companies right there who are really excited about having like off-peak power if they could. So if you're able to work with them, you can provide them off-peak power that reduces cost to everybody. Then you've got consumers even around you who may have power nearby. They might have a small bit of power, but they don't have a lot, and you could aggregate for them. In our case, we also have EV charging stations planned in our system. Our battery charger doubles as an EV charging charger and also charges batteries, like an extremely ultra fast charging system. So we can provide low cost, ultra fast charge to EVs, particularly trucks who have larger needs. So suddenly you're starting to make a difference. You can do frequency regulation. You can do, you're bringing cheap power into the market, and the transmission constraint is no longer the big problem. And once we can scale these up in a very large scale, and I'm talking like hundreds of megawatts near multiple substations, then suddenly the transmission hurdle does not become as big an issue as it was. That we know that we need to wait a long time for the next transmission upgrade to come. And again, we'll bring back the price for what it was 10, 20 years ago. But now you have accessibility of power. It's lower cost. You have now all kinds of people, let's say DRs can integrate with it. The more and bigger issue now is that if you're going to have electrical buildings, if you're going to have edge, like for example, Manhattan, You need to bring edge AI servers into Manhattan if you want to be competitive. I'm sure they're doing it. But those data servers suddenly go over, like they suddenly need like 40 megawatts, and the next second they don't. Like who knows who's using it, right? Like suddenly one person's maybe crunching a lot of data. So you need to have capacity close to the use. And that means that those power plants I talked about earlier that are doing all that capacity, a lot of those are gas fueled power plants. They're expensive. They should be doing other things. You could be using as a battery as a capacity resource at a much lower cost, particularly in our case, as I mentioned throughout much our LCOS. That suddenly brings the cost of capacity down. Guess what that does? That 20%, 40%, 24% price increase you're seeing on ratepayers because of all the capacity fees from data servers and other, that's going to come down. If New York wants to see rapid building electrification, that means suddenly these gigantic buildings at 4 p.m. at 40 stories high are going to have tens of megawatt of power in 1 second. Wires would explode if you don't have a very, very rapid resource nearby that can handle it. That's very expensive to do unless you find the unit economics to make it work. And it has to be close by. So that's what we're doing.
Cool. So that's a great vision. I love it. What's the status of the company? When are you going to actually deploy technology, do you think?
So we're on a roadmap to, we're currently starting our pre-seed round. We're actually have a few investors that have already, spoken to us and said they want to help us close a round. And then we're going to plan to get into our first test location, and our focus, as always was, in New York by 2027. That's always been our roadmap. And then after that, we look to scale up rapidly and through the next 3 years and with new investment partners and scale that up. But we want to test out. Our focus right now is to get in front of the New York Fire Department, New York Building Department, the new mayor's office, and make sure that they feel extremely comfortable and they see that. I've already ran this by really great fire specialists and code consultants. So we know that this is really where things need to go, but I'm excited to get that. And then after that, we can scale up. Yeah.
And can you talk about the seed round at all? Like how much are you trying to raise for the seed round?
Yeah. So our seed round is going to be around 100 million. The pre-seed round is looking substantially smaller, but it's a small round. We're raising right now about $1.5 million, which, as I said, is already kind of called for, which is going to get us to finish a lot of the hardware design that we wanted to certify and put into the main system. And after that, we're going to build out the production line and put the first site into the city. And yes, and we're on the lookout. We're already looking at Chicago. We're looking at Boston. I've already started to look in LA, but we need to be focused on where we know we make the biggest difference. New York State and New York City has always been very interested in batteries. We have people who worked with Con Ed who are on our advisory team. There are a lot of great people who've been extremely helpful, who've been coming in and helping us. So this is a great place to launch, and from there we can expand once we see. But we need to focus right now on this launch pad.
I think there are a couple of bottlenecks for technology companies.
Yes.
There's people. You need more smart people. People are a limiting factor. Yeah. And you need connections and funding, right? Money, okay? And then you need some good luck and timing. Of those three things, I guess, what do you see as the greatest challenge for Karh at this stage?
If anything, I think it would be the money, but I think we're okay now on that level. I don't know what the seed round, that will always be something that I want to close. But again, we've already started having an early conversation. The seed investors I spoke with 4 years ago, when we were on the Cornell accelerator. And, I've been in contact with them. They just said, once you have the hardware ready, we're looking to look at it. Unit economics works, So I think we're in a really good position. I think there's always challenges. We're really lucky. I was lucky from the day one with people. This is kind of why I believe in Occam razor, like the fastest, slowest answer is always a true one. When I started on the journey in 2014, 2015, I had some of the best, scientists helping me right in the beginning. I think I mentioned some of them to you. And then I spoke with, heads of major government organizations who right away gave me the data. I mean, it was just like, wow, this is amazing. What's going on here? And then all the top integrators. And then when we start to build a team, right now we have an amazing team. We have engineers who used to work at FERC and Tennessee, Valley Authority on our team. We have literally like wizards designing our drive. I mean, I'm shocked. We have, the engineering, when we decided to build the drive, our battery charger, which is a 1500 volt DC, ultra fast charging at like 98% efficiency. And it's, we got to design that from when we proved the research to actual prototype. We're almost finishing simulation. It's being done in 6 weeks. I'm just shocked. Like, we're at this place where we have integrating knowledge among the team in such a way that it's just incredible. We have just a fantastic team. Of course, you met my co-founder, Daniel Bedard. This guy is a wizard. I mean, he's, 40 years he's been working on renewable systems and all kinds. He calls himself a physical engineer, but he's just one of the only, people in the world who knows kind of like everything he's like the Baba for energy storage. He knows all the different things about the technology as a mechanical expert. So yeah, in that sense, we had, someone who was who helped run things at the Brooklyn Navy Yard, who became an advisor to the company early on. So we're like really lucky getting involved in a very, very good access to the real estate, market, to the New York, understanding how that works. And we already spoke with the EDC. I had a first conversation with them. They're amazing people. So in terms of the connections, we've just been really lucky, and I hope that luck continues, And in terms of the team, I think the team has been just incredible. I mean, again, it's been extremely lucky to have that. Our data science team came in together. We have, we built the AI stack also in just a couple of months from the concept to development. So I'm really excited about that. So yeah, the funding has always been was always the issue, and that now is also being resolved. And I think the reason as a result because we just designed a lot of stuff that we can show to investors. They can see that, wow, okay, this is some pretty serious stuff. So it also came with organically.
Cool. Well, if you're listening to this and you want to invest in next generation energy storage technology, reach out to Christian or myself. Hey guys, are you a residential solar installer doing light commercial, but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. And Christian, where can our listeners find you?
I'm always available on LinkedIn, of course, Christian Farivar. Karh.energy is the website. The company is called Karh, but our URL is karh.energy. I'd love to chat with you. And if we don't end up working together on energy, we'd love to talk about innovation and complexity and crazy technology. That's really my sweet spot. I'm a hipster nerd, if you will, because you said I have the music background.
I love it. Well, check out all of our content at cleanpowerhour.com. I would love it if you're on a journey into large C&I and battery storage. If you would book a strategy call with me, just go to the strategy tab at cleanpowerhour.com and meet me at a conference. I go to many of the regional RE Pluses. I'll be at InterSolar San Diego at the beginning of 2026. And with that, I'll say, let's grow solar and storage. I want to thank Christian Farivar for coming on the show. Thanks so much, Christian.
Thank you so much for having me, Tim. It's been a pleasure. Look forward to staying in touch.
Let's grow solar and storage. I'm Tim Montague. The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.